Hi there and welcome to this class. For this class, we look at the concept of magnetic field. Let's discuss the full tutorial class on the topic called magnetic field. First things first, we'll start by defining magnets. After that, we'll look at the concept of magnetic field and then magnetism. Having said that, let's look at the concept one after the other. Let's start with magnetic field. What is a magnet? Let's look at the magnet. What is a magnet? What is a magnet? By definition, a magnet is an object that produces a magnetic field. It has a chemical formula F3O4 in the form F3O4. This means a magnet composed of three atom of iron and four atom of what there? Oxygen. So this is the compound or the chemical formula for magnet. So we said a magnet is an object that produces a magnetic field. Its chemical formula is given by F3O4. This means Fe is iron. So I need three atoms of iron and four atoms of hydrogen. This stuff combine together to form a magnet. I hope good now. This is how you define magnet. At this junction, let's look at another important concept called magnetic field. Magnetic field. All right. At this junction here, a magnetic field is a region or space where a magnetic force is felt by a body. A magnetic field is a region or space where the magnetic force is felt by a body. So a region or space where a magnetic force is being felt is called magnetic field, right? A space where a magnetic force is being experienced. So anywhere you experience F3O4, that area or that specific region is called magnetic field. How good that? So I'll define magnet. Or look at magnetic field. Let's look at magnetism. Let's look at magnetism. So what is magnetism? Alright. Magnetism is a physical phenomenon produced by the motion of electric charges which result in attractive and repulsive forces between objects. This is how you define magnetism. So we have looked at the three different definitions for magnetic field. We look at magnetic itself, magnetic field, and magnetism. At this junction, let's look at another important heading called production of magnetic field. Production of magnetic field. Production of magnetic field. All right. This is another important aspect here called production of magnetic field. All right. This concept talks about how do we produce magnetic field. What are the several ways to which, if I apply this process, magnetic field could be generated? There are two. Number one, please. Number one is called motion of electric charges. Number one is called motion of electric charges. Motion of what the electric charges, or you call it electrical current in bracket. Current. All right. This one here is the first way of producing what the magnetic field. Motion of electric charge. So it means that when a charge is at motion, it means that electric field or magnetic field is being produced. So the first way to produce magnetic field is by what there? By motion of electric charges or perhaps electrical current. Number two, the second way of producing magnetic field, number two is called use of magnet. Use of magnet or perhaps use of a magnet. All right, if I use magnet, right, in any occasion, it means that I am actually leading to a process of what there of producing magnetic field. These ones here are simply the through production, the two ways to which you can produce magnetic field. Having said this, note please, note n/b, note. The electric field produced by a bar magnet is given below. Note please, note. The electric field produced by a bar magnet is given below. Alright, let's draw this out please. Let's draw this out. Let's draw this out. The electric field produced by a bar magnet is given below please. Let's draw this out. Alright, I have this one here. Alright, so I have this move this way. 1, 2, alright, 3, alright, 4. Alright, similarly, I'll come down here. 1, no, 2, alright, alright. So this is the magnetic field, right? This is simply the electric field produced by a bar magnet, right? The electric field produced by a bar magnet. All right. All right. Here it's coming in, outward. It's going outward here, outward here. All right. So I have my arrow this way, this way. So this stuff here. Now listen and listen, please. Listen and listen. This is your diagram for electric field produced by a bar magnet, right? So having said this, I want you to take something here from the diagram. So want you to take away from this diagram is that if you watch out the diagram very well, you will note that the magnetic field flow from the magnetic field flow from the north pole to what the south pole, as you can see, from north pole to south pole, north pole to south pole, north pole to south pole, and then north pole to south pole. So your key take on this diagram is that magnetic field or magnetic field in per se flows from what the north pole to the what to the south pole, as you can see, and it's also moving inward and coming outward from here. So this is like the key take to note here is that magnetic field move from what from the north pole to what to south pole. All right. Having said this, there is something I keep on mentioning, which is called pole. North pole, south pole. What's a pole? Let's look at another important concept called pole. Pole. What's a pole? All right. Definition: a pole is simply the region of magnetic where the magnetic field is being produced. This is simply the region of a magnet where the magnetic field is being produced. All right, so if I have this way, this is called pole, right? So we have the North Pole and the South Pole. So this a pole is simply a region where the magnetic field is being produced, right? So we have the north. There are two. We have the two distance there. We have the North Pole and there are two poles in magnetic field. They are what there? The North Pole and the South Pole. So don't forget that a pole is where magnetic force or magnetic field is being experienced more or is being produced out, right? At this junction here, please note an important concept, please. Note. All right, note, please. Very important, please. Note. Current flow through a wire. Current flow through a wire produces electric fields. The direction of the electric field can be remembered using the right hand rule. I said current flow through a wire produces electric fields. The direction of the electric field can be remembered using the right hand rule. Alright, this particular note you just said now will take us to something called the right hand rule. So what is the law that governs the right hand rule? Alright, subheading please. Let's look at the concept of the right hand rule, please. The right hand rule. What's the idea behind the right hand rule? Alright. Alright, let's look at the concept of right hand rule, please. Right hand rule. Right hand rule. So what's the concept behind the right hand rule? Put up please. The right hand rule states that if one grabs a wire with the right hand in such a way that the thumb is in the direction of the current, the finger will encircle the wire in the direction of the magnetic field. As you can see, the diagram of right hand rule are displayed on my left hand side, as you can see. So we said that the right hand rule states that if one grabs a wire with the right hand in such a way that the thumb is in the direction of the current, the finger will encircle the wire in direction of what there of the magnetic field. What do we mean? So we said, listen to this please. It says if one grabs a wire, so I'm saying this, let this be a wire. So if, as you can see diagram, as explained diagram, so if one grabs a wire such that the thumb is the direction of current, so we are assuming that let's say I'm going the wire this way and the current is flowing straightward, right? Straight up this way. I have the current here, so my hand is here, so my thumb is here, right? And my hand this way. Let me just avoid this. We'll get to understand this much more better as we proceed. Let me waste my time here. We have a lot to cover. I will explain that right hand rule much more later as when we want to solve some problems. That's when you understand it very well. So I'm saying that it is the right hand. That right hand rule says that if one grabs a wire with the right hand in such a way that the thumb is in the direction of what? Of the current. What happens there? The finger will encircle the wire in direction of the magnetic field. Having said this, now let's look at the concept of calculation based on magnetic field. All right, calculation, calculation based on magnetic field. All right, let's look at some of the calculation that can be done under the study of magnetic field. All right, calculation based on magnetic field. There are now in this concept here, there are two cases here. We'll do case one and case two. Right? Let's do case one and case two. After that, in our next video, we'll now solve several past questions in the study of magnetic field or perhaps magnetism. All right. Let's look at calculation based on magnetic field. Let's start with case one. Case one. For case one. For case one. All right. For case one, please. For case one. Note. Note. Given a conductor of length L, given a conductor of length L, carrying current, I, carrying current I, and inclined at an angle theta to the magnetic field B, as shown below. I said, given a conductor of length L, carrying a current I, and inclined at an angle theta to the magnetic field, of course, B, as shown below. All right, I have this place. I have this. All right. Okay. Direction is this. Have this. So we said, so let's say my conductor is this. This is my conductor. Let's assume this is my conductor that passes my current. So this conductor has in it a current I, right? This conductor is inclined at an angle theta to where? To the magnetic field, as you can see. This magnetic field here, right? Theta. So, and this conductor has a length. So from here to here is what? It's called the length of conductor. The length of conductor L. Length of conductor. Right? Alright, so that becomes your length of, so from here to here is your length of conductor. This conductor is not straight, it's at an inclined to the magnetic field at an angle theta. Why this conductor here has a current flowing through it, I. So having said this, so I said that given a conductor L of length L carrying a current I and inclined an angle theta to the magnetic field, hence the force on the conductor, hence the force on the conductor F. What will be the force of the conductor? So the force of the conductor F will be equal to ILB sine theta. All right. In a case whereby you are having your length, your current, your theta, and your magnetic field, note that the force of attraction, or perhaps the force on the conductor F will be equal to what? The ILB sine theta. Let's define parameter where F signifies force on conductor. Force on conductor carrying current. Of course, in brackets, Newton. What is in Newton? We also have the I is called current, right? Your current carried by the conductor carried by the conductor in brackets ampere, right? We have the length L is called length of the conductor in brackets in meters. Length is measured in meters, right? Proceeding, length, we have theta, that's called angle of inclination. Angle of inclination, angle of what? The inclination of the conductor to the magnetic field. Of the conductor to the magnetic field. All right, this is how you define them, right? Theta. Once again, they have B. B is where? B is called the magnetic field. What's the unit? This one is theta is angle, right? What's the unit for magnetic field? That's magnetic field, or call it magnetic intensity. What's the unit here? Tesla. T. Tesla is the unit. Tesla. Capital T. If I have 5 Tesla, it means what? That's magnetic field. 5 magnetic field. So Tesla is the essence for what? The magnetic field. Alright. This is how you define each given parameter from the question. Alright. Note please. Note. I haven't said it, please. Note. I'm giving you 2 things to note, please. Note 2 things. Note number 1. Note number 1. Note number 1. The maximum force that is experienced by a conductor, the maximum force that is experienced by a conductor in the magnetic field will occur when the conductor is parallel to the magnetic field. The maximum force that is experienced by a conductor in magnetic field will occur when the conductor is perpendicular to the magnetic field. What are we saying? We are saying that if the conductor, or perhaps if we have, in this case here, what of if the force is maximum? What will happen to the conductor, right? So we are saying that for maximum force, that the magnetic field will occur when the conductor is parallel. So this conductor here, whenever it is parallel in this way, look up please. Conductor is like this, look up. Is parallel, is forming 90 degrees. In a case like this, your conductor, your force of magnetic field will be at maximum. Why? Because the conductor is acting perpendicular to the magnetic field, right? So whenever your conductor is acting perpendicular to magnetic field, it means that that conductor has a maximum magnetic force, right? So we're saying that it will occur when the conductor is there parallel to the magnetic field. So it means that for maximum force, F maximum, we said that the condition there is that theta will be what there? Theta will be what? 90 degree. So it means that if we have maximum force, theta is what? 90 degree. Why? Because the conductor is what? Acting perpendicular. In a case like this, what will not be the formula for maximum force? So if your conductor, or your maximum, your force, your conductor is a maximum force, what formula will you apply? Let's see how that works. So from here, from this concept here, we know that F is equal to what there? ILB sine theta. For maximum force, let me call it F max. For maximum force, F max is equal to what there? I L B sine into, for maximum force, we set theta is what? 90 degrees. I have 90, yeah? What I work on this gives you sine 90. Sine 90 is of course 1 is 1, right? So it means that my F maximum force will be equal to ILB into 1, because sine 90 is 1. So that in other words, for maximum force, the formula becomes ILB. When your conductor is perpendicular to the magnetic field, it means that the force of the magnetic field is maximum. And formula is what there? FLB, right? ILB per se as the maximum force. Now, in a case, for the case one, for number note one was that when the forces are at maximum, what are the forces at minimum, right? Note number two, please. Note number two, please. The minimum force that is experienced by a conductor, the minimum force that is experienced by a conductor in the magnetic field will occur when the conductor is parallel to the magnetic field. So for number two, when you have your magnetic field this way and your conductor is parallel to magnetic field this way, like this, it means that theta in this case is what the 0 degrees or 0 you want to, because it's parallel. So theta is what? It's 0. So in a case whereby you have a minimum force, for minimum force, what's the idea by minimum force? It means that the conductor is what? Is at what? Parallel, right? So in a case like this, what would not be the formula for F minimum in that case? So from here, I will record this formula. Record that F equal to ILB sine theta. So in this case, for F minimum, I'll have that ILB sine into 0. What sine 0? Of course, sine 0 is 0. So sine 0 is equal to 0, right? So it means that my F minimum will be equal to what there? ILB into 0. If 0 times anything gives you 0. So it means that the minimum force is equal to what there? Is equal to 0. So for the minimum force, your formula is what there? Is 0. So it's nothing, right? So now this is your formula to case 1 when it comes to calculation based on magnetic field. Before we move on, let's try to write out the formula in vector form. So in vector form, your magnetic field force is given by F is equal to, in a bracket, I L dot across B. Of course, this we have, if you want to, sine theta. This is how you represent your force, or perhaps you call it you represent your force, or perhaps you call it the force or on the conductor, right? If you want to. So this is better form of the formula. This is a case 1 when it comes to calculation based on magnetic field. This case 1. The next class we'll look at case 2 and then move on to other past questions. So we'll apply case 1 and case 2 much more in our next video, solving past questions. So one of my mission and goal is to impact life and teach people all over the world. and I can't do this alone. So I want you guys to support me. So by liking this video, share the video to your classmates and friends, subscribe to this channel if it's your first time, and do well to turn on the notification button so you can get notified whenever you drop a content. And also, if you're interested in joining a WhatsApp group, I have a WhatsApp channel and a WhatsApp group. The link of the two groups are in this and the video description. So check the video description. You see the two links to the two of them. So join the two of them, right? So you can have updates on how our classes works. If you also need a one-on-one section with me, you can book a call with me. You see my WhatsApp number there. You can message me up that you need a one-on-one section, either counseling or tutorial classes or whatever there. You can reach out to me and free chat to me freely, right? And I'll give you and engage you guys. All right, see you in the next class. We'll look at the second case when it comes to calculation based on magnetic field. Thanks for watching and welcome to Excellent Link Academy.
Before we continue this lesson, I want to share something that will make your learning experience even better. I now have exclusive channel memberships designed to help you learn faster, get direct support, and access premium content you won't find in my regular videos. The first level is the support membership. If you enjoy my lessons and want to support the channel while getting special perks, this is for you. It's a simple way to show appreciation and help me continue creating high-quality educational content. The second level is the WAEC and JAMB classes membership. If you're preparing for WAEC or JAMB, this membership gives you structured lessons, practice questions, exam strategies, and step-by-step guidance to boost your performance. The third level is the 100-level students membership. This is perfect for secondary school students who want organized, easy-to-understand lessons in physics, chemistry, mathematics, and other subjects. And finally, we have the YouTube Mastery membership. If you want to learn how to grow on YouTube, how to create content, edit videos, design thumbnails, and monetize your channel, this membership will guide you from beginner to creator. Whatever stage you are in, there's a membership designed to help you learn smarter, improve faster, and stay ahead. To join, simply click the membership link in the video description. Choose the level that matches your goals and start enjoying all the exclusive benefits. Before we continue with this lesson, I'm excited to announce that I just launched my official website, a complete learning platform designed to help you study smarter, learn faster, and access high-quality educational resources anytime you need them. On the website, you'll find several well-structured courses created to guide you step by step through the most important topics. First, we have Organic Chemistry for Beginners, a simple, beginner-friendly course that breaks down organic chemistry into easy explanations anyone can understand. Next, there are WAEC and JAMB classes, specially designed to help you pass your exams with confidence using clear lessons, solve questions, and exam strategies. We also have the physics tutorial for Year 1 students, covering foundational concepts you must master in your first year of higher education. And for anyone who wants to grow online, there is a complete course on how to start, grow, and earn on YouTube using only your smartphone. This course gives you everything you need to begin your YouTube journey without expensive equipment. There is also a book section on the website where you can get all my educational books, including the shortcut to academic success. My website is now your one-stop platform for science tutorials, exam preparation, YouTube training, and learning resources that can transform your academic and digital journey. To explore all the courses and get your copy of the books, simply click the website link in the video description. Hold on, before you continue this lesson, I need to tell you something important. If you've been struggling with studying, losing motivation, or you feel like you're working hard, but your results aren't showing, this is for you. I recently released a powerful book titled The Shortcut to Academic Success. It is a simple, practical guide that shows you exactly how to study smarter, stay focused, remember more, and achieve outstanding results without stress. This book is not theory. It's a step-by-step roadmap I created after years of teaching students and understanding what truly works. Inside, you'll discover proven study techniques, exam strategies, productivity hacks, memory boosters, and secrets top students use every day. Whether you are in secondary school, university, or preparing for any exam, this book will transform the way you learn and help you reach your academic goals faster. And the best part? It costs only 2,000 Nigerian nairas, less than the price of a snack, but the value inside can change your entire academic journey. If you truly want to upgrade your grades and finally take control of your learning, don't wait. Get your copy of the shortcut to academic success today. Your future self will thank you. Before we continue, let me quickly share something that can change your entire online journey. I just launched a complete YouTube mastery course, a step-by-step training designed to help beginners start and grow a successful YouTube channel using only their smartphone. In this course, I break everything down in simple, practical lessons. No expensive camera, no studio, no complicated equipment, just your phone and the right knowledge. You will learn how to create quality videos, design engaging thumbnails, write perfect titles, choose the right niche, understand the YouTube algorithm, and grow your channel from zero, even if you've never created a video before. If you want to become an online teacher like me, this course will guide you on how to teach online record lessons, explain concepts clearly, and attract the right audience. And if you want to create content in any other field, lifestyle, motivation, entertainment, business, this course will still show you the exact steps to succeed. All the lessons are pre-recorded, well-organized, and easy to follow. You can watch them at your own pace, anytime, anywhere. So, if you've been dreaming of starting a YouTube channel but didn't know how to begin, this is your opportunity. This course will take you from beginner to confident creator. The link to get the YouTube Mastery course is right there in the video description. Click it and start your YouTube journey today.